So I am here again with the SC Verma solution. This time question number 50 and 51 from chapter 3 in kinematics. This problem, question number 50 is quite easy. 51 is also easy, but just a little bit tricky. Slight, you need to know a little thing about how the sound waves are moving, how it's reaching this. So let me describe the problem first. It's there in this problem sheet. I will not write the whole problem. You already have that in the book because you already have tried. If you have not tried it, just try it, at least for the sake of understanding the question. So the question is, we have two persons, A and B. Let's say, and these persons are standing at distance x apart. This is the distance x between them. Wind is blowing from A to B. Let's say he is A and then this is B, and wind is blowing from A to B at some speed u. A beats the drum and B hears at time t1 times later. This person has a drum and he beats the drum, and then B listens it. This is the speed of the sound, and B listens it after time t1. This is what's happening. So obviously the sound wave will move with a faster velocity because it's helped by the speed of the sound. So the effective velocity of the sound moving is v plus u. So we have this equation, x distance covered with the velocity v plus u multiplied by this time t1. So what the next thing he does is that they interchange their position. When they interchange their position, so A takes his drums and comes here, and B moves here. The drum is here, still here. He starts again beating the drum. The wind is blowing this way, and he beats the drum. The sound moves with the velocity v, but wind this time is now acting against it. When the wind is acting against it, it will move with a smaller speed and it will take time, less time, and that time, this time is given as t2. But the distance it has to still cover x, so we have this equation, x is equal to v minus u and a smaller time and a higher time t2. t2 will be longer because the speed is come, it moves moving slowly. And from here we need to calculate the speed of the sound in the still air and the wind velocity. Now all we need to do is solve these two equations. We will rearrange these equations and write it as v into t1, this one, plus u into t1 is equal to this x here. And this becomes v into t2 minus u into t2 is equal to x. And from here we need to find out v and u. How do we do that? Multiply this equation by t2. Let's try to eliminate this one because the signs are plus and minus, easy to eliminate. Just add them and they get eliminated. Multiply this one by t2, this becomes t1 t2. Multiply this one by t1, this becomes t2 t1, and add them. And you add them, this becomes v t1 t2, and then again v t2 t1 plus v t2 t1 is equal to x common t2 plus t1. This is v 2v t1 t2 is equal to x t1 plus t2. We can find out v by, take t1 t2 on that side, x upon 2 t1 plus t2 divided by t1 t2. You can also write it as x upon 2 1 upon t1 plus 1 upon t2. This is the velocity. This is the first part is done. This is the speed of the sound. Now what is the speed of the air? Find the speed of the air u. We do the similar thing. This time we need to eliminate v from here. So what we do is, to eliminate v, we still multiply this one by t2, this one by t1, but this time we subtract this and v gets eliminated. So when we subtract this equation on the right hand side, we get x t2 minus t1. That is on the right hand side. On the left hand side, this gets eliminated, vt1 t2 multiplied by vt2 t1 gets eliminated, and we are subtracting this minus these two gets added. So ut1 t2 and then minus subtracting of ut2 t1. That is 2u t2 t1 is equal to x times of t2 minus t1. So 2 goes this side, becomes x by 2, and t2 divided by t2 t1. So t2 goes away, we have only t1 here, 1 upon t1 minus 1 upon t2. This is the speed of the wind. As we said, t2 is a bigger number. So this is a bigger number. So 1 upon t2 will be smaller. That's why we can subtract it and you will still be positive. Which means that the directions we took is right. So that is question number 50. Nothing very special about it. It's simple. The part 52, we need to think a little bit. And that's where in part 51. In 51, A and B change their positions in such a way such that the line joining them is perpendicular to the direction of the wind. Now A and B were here, we are changing their position like this. This is A and this is B. Okay, the wind is still blowing like this in this direction, let's say. Wind is blowing in. It doesn't matter, you take it this way or this way, problem is still same. I am assuming that the wind is blowing with a velocity u in this direction. And the separation between them is still x. Now what happens is, A is beating the drum. What happening is that when A beats a drum here, he has a drum, and when he beats the drum, the sound wave would usually flow in this direction. So let's say A is beating the drum, then sound wave starts propagating in this direction. But what the wind does is, wind is blowing, so this sound which is going in this direction, it will be a little deflected in this direction. By the time, and more, so the sound wave which was trying to travel in this direction actually lands up here. So B may either miss it or may hear it a little later. But the trick is, the sound waves are going in all directions, here, 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 here. Let's think, the sound which are going in this direction will go here, would have liked to go here, but because of this wave, this air blowing, it will land even further. But a sound wave which is going somewhere in this direction, let's say, and would have liked to reach here, is helped by this wind blowing in this direction, and that will bring this sound wave, by the time it reaches, it will bring it at B, which is the first sound that this person will hear from A. And let us say this angle is theta. The speed of this is the speed of the sound in the still air, and that we call it as, let's call it as V, and this velocity is u. So the time it will take to reach this sound wave, to reach B, will be this distance x divided by v cos theta, the component of this velocity along this direction. This is going to be v cos theta, and cos theta is equal to this velocity divided by this velocity. since this is V and this is U, this is going to be square root of V square minus U square. This is how we can find out cos theta. This is x upon V. Cos theta is square root of V square minus U square divided by V. This cancels. The time taken will be x divided by square root of V square minus U square. This is our answer. I hope you helped it. Try to think a little more about these things, how the things are happening, but just keep in mind, you can understand it many ways, that this sound wave goes into many directions, and the one that this goes in this direction will not be the first to be heard by B. The one going a little on this direction will be the first that will be heard by B, because even though it's moving in this direction, by the time it reaches here, it will be coming along this path, and that is the one that will reach B and will be heard by B.